Hello, honors, and welcome to your study guide video. We're just going to go through this and have a great time doing it. Okay, let's start with number 1. So we are going to simplify, which just means combine everything that we need to combine, make everything positive, and that's that. So the first thing I do is look at my outside exponents. I have a -3. So the first thing I want to do is make that positive by moving it. So to make it positive, we're going to move it to the bottom. So I'm just going to rewrite it over here. Okay, so we have 4x squared, y cubed squared, all over. This is going to stay the same. 2x to the -2nd, y to the -5th to the 4th power. And then everything on the inside of the exponents is going to stay the same. So 2x to the -1, y, but now that 3 on the outside is going to be positive. Okay, so once I've made all the outside exponents positive, I'm now just going to distribute my exponents and, into the parentheses. So it's going to be 4 squared, the x to the x2 to the y3. Then the 4 is going to go to the 2, to the x to the -2, the y to the -5. Then the 3 is going to go to the 2, the -1, and the y1. So remember with this, it's really 4 to the 1st power. So what you're multiplying is the 1 times 2. So it becomes 4 squared. 4 squared we know is 16. And then 2 times 2, now because it's power to a power, we're multiplying. And then 3 times 2 is 6. Okay, 2 to the 4th. So 2 to the 4th is 16. -2 times 4 is -8. -5 times 4 is -20. And then right below it, 2 to the 3rd power is 8. -1 times 3 is -3. And then 1 times 3 is +3. So you have 2 options here. You can start to combine the bottom and then move whatever is left that's negative to the top, or you can start moving right off the bat. What I am going to do is I think I'm going to combine first. I do recognize that I have a 16 on top and a 16 on bottom. So what I'm actually going to do is I'm going to cancel those out because 16 divided by 16 is just 1. So from there, what I'm going to do, like I said, is combine on the bottom. So I can combine -8x to the -8th power and x to the -3rd power. And I'm just combining them by adding them. So -8 plus -3 is -11. So everything on top is just going to stay the same. So that would be x to the -11th. And then we can do the same thing here. We can add those. So -20 plus 3 would get me -17. So that would be y to the -17th power. And then I can't forget that 8, so I'm going to add it to the front. Okay, so then the last step is to make all of our negative exponents positive. So that means this -17, to make that positive, it's going to go to the top. Same thing with the -11. To make that positive, we're going to move that to the top. So I'm going to go over here and continue with the problem. So x to the 4th, y to the 6th don't change. But now x to the 11th is going to be on top and positive, and y to the 17th is going to be on top and positive. And then divided by 8. So then I can start to combine my like terms. So x to the 4th and x to the 11th can now combine. 4 plus 11 is 15. And then 6 plus 17 is 23. I had to think about that one. And then the 8 just stays in the denominator. We can't move it. It doesn't have a negative exponent, so it just stays as is, and that is my final answer. So x to the 15th, y to the 23rd, all divided by 8. And that does it for number 1. Okay, let's continue on to number 2. Okay, so for number 2, says find the domain of the function. Remember, to find the domain of a rational function, and that's a rational function because there's a variable in the denominator. To find the domain of a rational function, we're finding our excluded values. The excluded values are any x value that makes the denominator 0. So what we want to do is figure out what x values make the denominator 0 and solve for that. So what we do is we just take our denominator. So all we're looking at is the denominator here. And then we're going to set that equal to 0. So 2x squared minus 7x plus 6 equals 0. So whenever we have a quadratic and it's set equal to 0 and we want to solve for x, we can either solve this by factoring or we can solve this by using the quadratic formula. Now I would prefer to factor, so I'm going to try factoring first. So remember, on top is 2 times 6, which is 12. And we're seeing what two numbers multiply together to get me 12 and add to get me negative 7. And so those two numbers, it works out, are negative 3 and negative 4. Negative 3 times negative 4 gets me a positive 12, and negative 3 plus negative 4 gets me negative 7. So because a is greater than 1, I have to split the middle term here. So 2x squared. I think which one goes better with 2, 3 or 4? And I'm going to put it with 4. And then 3x is going to go with 6. And now that I have 4 terms, I can factor by grouping. So I look here at the first 2 terms and then at the last 2 terms. So 2x squared minus 4x, I can factor out a 2x, and I'm left with x minus 2. Negative 3x plus 6, I can factor out a negative 3. Negative 3x divided by negative 3 is x, and 6 divided by negative 3 is negative 2. Are these the same? They are. They have to be, or I've done something wrong. So now my final factored answer is 2x minus 3 times x minus 2. So now that it's factored is now how I can solve for x. So now what I'm going to do is set each factor, 2x minus 3 equal to 0, and set, okay, I honestly just paused, so I'm hoping that I pick up right where I was because someone stopped by. So we moved 2x minus 3. We set that one equal to 0. Now we're going to set our other factor equal to 0. And now that we have both factors equal to 0, we can solve for x. So add 3 to both sides, divide by 2. And so one of my excluded values is 3/2. Now I'm going to add 2 to both sides, and the other excluded value is 2. So remember, I do want you guys to write this in interval notation. So it can't be equal to 3/2 and it can't be equal to 2. So to write that, remember, in interval notation, you're writing it from least to greatest. So if you need to draw out your number line, draw out your number line. But essentially what's going to happen is it's going to be negative infinity. It can't be equal to 3/2. 3/2 is less than 2. Then can't be equal to 3/2. It goes from 3/2 to 2. Can't be equal to any of those, which is why we use a parentheses. And then union to infinity. And that is how you would write it in interval notation. Okay, 16x squared minus 64, factor. So for this one, there's a lot of different ways that you can actually approach this. You could first just factor difference of squares. But what I would do first is actually factor out the GCF. So there's a GCF there of 16 that we can factor out. So I can factor out the 16 first. And then I'm left with x squared minus 4. And then now I can factor that difference of squared. That is a difference of squares. X squared and 4 are both perfect squares. There's subtracting. There's 2 terms. So the square root of x squared is x. The square root of 4 is 2. So it's x plus 2, x minus 2. And that is completely factored. Remember, it doesn't matter which order you put those in, as long as you have them both there. Okay, number 4, 25x squared plus 4. So we look at that one and we want to say originally difference of squares. But with difference of squares, remember what's important is that they're subtracting. That's why it's difference of squares. Now, because this one is not subtracting, this is a plus in the middle. This is not a difference of squares. And so what that means is this one can't actually be factored. And so when something can't be factored, we call that prime. So prime means that something cannot be factored. Okay, let's move on to 5. So 2x cubed minus 8x squared minus 24x. First thing I look for always is a GCF. Between 2x cubed, 8x squared, 24x, I can factor out both a number and a variable. I can factor out 2x. And I'd be left with x squared minus 4x minus 12. And then I can see, like I always want to check, can I keep factoring the inside, which I can. I'm thinking what two numbers multiply together to get me 12, negative 12, and add to get me negative 4. And that's going to be negative 6 and positive 2. So because a is equal to 1, I don't have to split the middle term like I did up here. I do when a is greater than 1. But when a is equal to 1, I can just go ahead and do 2x times x minus 6 times x plus 2. If you wanted to split the middle term and use those and do the method that we did above, that's fine too. Works. Okay, so then it is fully factored. Okay, let's keep going. So number 6 is asking us to factor. I first look to see, is there a GCF? There isn't. So I go on and I'm 3 terms. I use my x. 6 times negative 20 is what's going to go on top. So negative 120 and then negative 7. So I'm thinking what two numbers multiply together to get me negative 120 and add to get me negative 7. So little trial and error, I got that to be negative 15 and positive 8. So then I have to split my middle term because a is greater than 1. So 6x squared, I think which one goes better with 6, 15, or 8? Really, they both do, but I'm going to put the minus 15x with it. Plus 8x minus 20. Remember, this order doesn't matter. You can switch them around. It will get you to the same point. Now that I have 4 terms, I factor by grouping. So 6x squared minus 15x, I can factor out a 3x. And I'm left with 2x minus 5. I always bring down my middle sign. 8x minus 20, I can factor out a 4. And I'm left with 2x minus 5. Remember, these have to be the same. If they're not, go back, check your work. And then factored, 3x plus 4 times 2x minus 5 is my final answer. Remember, you guys can always check your work by remultiplying it back together. If you get to the same answer, then you've done it correct. Okay, number 7, x cubed minus 100, or 1,000, sorry. So with those, whenever I see a cubed in the problem, I'm thinking SOAP. Remember, SOAP is our formula that we use. So I'm thinking, what's the cube root of x cubed? That's x. And then what's the cube root of 1,000? And that's 10. So remember, the factoring, like, really is just a pattern. Every single time it's the same. So it's the first term, same sign, last term. And then first term squared, so x squared, opposite sign. The two terms multiplied together, so x times 10, which we write as 10x. Always positive, my last term squared. So 10 squared is 100. And that's it. Okay, let's move on to 8. 8 is also a sum of cubes. So we are going to, again, think what's the cube root of 125x cubed? And that is 5x cubed. And then what's the cube root of 64y cubed? And that's 4y. So I'm actually going to do this one here and then transfer it over. So the first parenthesis is always pretty easy. It's 5x first term, same sign, so plus the second term, 4y. And then it's the first term squared. So it's 5x squared. Remember, it's 5 is being squared and x is being squared, so it's 25x squared. Opposite sign, so minus 5x times 4y. So 5x times 4y is 20xy. And then always positive is going to be 4y, the last term, squared. And again, that's squaring the 4, squaring the y, and so that's 16y squared. So my final answer would be 5x plus 4y times 25x squared minus 20xy plus 16y squared. Okay, number 9. So number 9 says find the x and y intercepts given the equation y equals x squared minus 10x minus 24. Write your answer as ordered pairs. So let's first start with the x-intercept. Remember, the x-intercept is where y is equal to 0. So what I'm going to do is use my equation. I'm going to set the equation equal to 0 because I'm setting y equal to 0. So 0 equals x squared minus 10x minus 24. Now I have to solve for x, and I have a quadratic. Remember, whenever we have a quadratic, it's set equal to 0, and I need to solve for x. I can do that by factoring, if I can. If you can't factor, then you need to solve using the quadratic formula. But I can factor this one. So I'm thinking what two numbers multiply together to get me negative 24 and add to get me negative 10, and that would be negative 12 and positive 2. So I'm actually going to move that over. So x minus 12 and x plus 2, and then the 0. I'm just moving the 0 on the other side. And now that it's completely factored, I can set each factor equal to 0 and solve for x. So move the 12 over, that becomes x equals 12. Move the 2 over, that becomes x equals negative 2. So to write that in ordered pairs, remember, we plugged in 0 for y. So we already have our y value. This is 12, 0, and then negative 2, 0. Okay, and then my y-intercept is always the easier of the two. Your y-intercept is where x is equal to 0. So that means I just plug in 0 wherever there's an x and solve for y. So y equals 0 squared minus 10 times 0 minus 24. Well, 0 squared is 0. 10 times 0 is 0. Minus 24. Where is my whiteout? Minus 24. And then, okay, so that just gets me negative 24 for my y value. Then to write that as an ordered pair, we know the y is equal to negative 24, and we know the x is equal to 0. So it'd be 0, negative 24. Okay, let's go on to 10. So 10 says, same thing, find the x and y intercepts. So first thing we're going to do is find our x-intercepts, which again is where y is equal to 0. So that means I'm going to set my equation equal to 0. So that's going to be 0 equals x squared minus 8x minus 48 divided by 3x plus 7. Well, the first thing we would do when solving this and going through this process is we'd want to actually get rid of the denominator. And to get rid of the denominator, what we would do is multiply both sides by that denominator. So I'm going to multiply this side by 3x plus 7, because that's going to end up canceling. And then I'm also going to multiply this side by 3x plus 7. So what happens is 3x plus 7 times 0 is 0. And then 3x plus 7 times 3x plus 7, those cancel, and I'm left with just x squared minus 8x minus 48. And so now I'm at basically the same spot I was up above. I have a quadratic. To solve a quadratic and get x's by itself, we need to factor or use the quadratic formula, but I can factor here. What are my two numbers that multiply together to get me negative 48 and add to get me negative 8? And that would be negative 12 and positive 4. So I can factor that. X minus 12, x plus 4 equals 0. Now that it's fully factored, I can set each factor equal to 0. I'm going to move that up here. So x minus 12 equals 0 and x plus 4 equals 0. Solve for both of them. I get x equals positive 12 and x equals negative 4. So for my x-intercepts, we know my x values, my y values are always 0, 12, 0, and negative 4, 0. And then we move on. So let's move on to our y-intercept. Your y-intercept, again, is where x is equal to 0. So we're just going to plug in 0 wherever there's an x. So y equals 0 squared minus 8 times 0 minus 48 divided by 3 times 0 plus 7. Well, 0 squared is 0. 8 times 0 is 0. Minus 48, so 0 minus 48 is negative 48. 3 times 0 is 0, and 0 plus 7 is 7. Can I simplify that further? I can't. And so just keep it as a fraction. So then my y-intercept as an ordered pair would be 0, negative 48 sevenths. And that does it for x and y-intercepts. Okay, so number 11, write the equation of the line that passes through the points 2, -6 and 5, -1. Whenever you are finding the equation of the line, the first thing you should be looking for is the slope. So to find the slope, we need to use our slope formula. And so that's x1, y1, x2, y2. And remember the slope formula is y2 minus y1 over x2 minus x1. So y2 is -1 minus y1, which is -6, all over 5 minus 2. Negative and a negative make a positive. So -1 plus 6 is 5. And 5 minus 2 is 3. So my slope here is 5/3. So from there, now that I have my slope, I'm going to use point slope form. Remember, point slope form is y minus y1 equals m times x minus x1. And I can use either point. It doesn't matter. I'm just going to use 2 and -6. So that's going to be y minus -6 equals 5/3 x minus 2. First thing, that minus and a minus make a positive. And then I need to distribute the 5/3 to both the x and the -2. So that becomes y plus 6 equals 5/3 x. And then -2 times 5/3 is just -10/3. Because you just multiply the tops together. And then to get my final answer, I would subtract 6. And I'm just going to do that in my calculator. So in my calculator, let's see if you guys can see that. Kind of. Okay, so I would do -10/3, I think. Yep. Minus 6. I would get that decimal, but remember you can press math and then frac, and it converts it to a fraction. So minus 28/3. So that's my final answer. Y equals 5/3 x minus 28/3. And that does it for 11. Okay, let's move on to 12. Getting through it. Okay, So number 12 says write the equation of the line that has an x-intercept at -5 and a y-intercept at -2. Well, this is kind of taking that information that we learned from 2-2 and applying it to also 2-4. So we know an x-intercept, that's telling me the x value. Well, at every x-intercept, we know that the y value is 0. So we have an ordered pair here. The ordered pair is -5, 0. Same with the y-intercept. We know the y value is -2. We know the x value is 0. So this point is 0, -2. So now this is actually really similar to problem 11. We just have to find the slope and then write it in y equals mx plus b form. So I have x1 and y1 and x2 and y2. So I'm just going to plug that into my equation. So y2 is -2 minus y1, which is 0, all over 0 minus -5. When you minus a minus, it becomes positive. -2 minus 0 is -2. And 0 plus 5 is 5. Now, you have two ways of how you can move forward with this. You can either plug it into y minus y1 equals m times x minus x1, just like we did on number 11. Use either point. Or we know that my goal is to get it in y equals mx plus b form. Well, I have my slope. My slope is -2/5. I already found that out. And my b, remember my b is my y-intercept. Well, I also already have my y-intercept. My y-intercept is -2. Your y-intercept is b. So I can just plug everything in. Y equals -2/5 x minus 2. And that's it. If you use point slope form, just like we did on 11, you should get to the same point, no matter which value you use, -5, 0 or 0, -2. Okay, number 13, write the equation of the line that has a slope that is undefined and passes through the point -2, 4. Super important. One of those words that's super important to me is undefined. That tells me I'm thinking about vex. Vertical line, undefined slope, x is equal to the equation. So all that I care about here is my x value. My x value is -2, and that's my equation. X equals -2. And that's it. So 14 says write the equation of the line that has a slope equal to 0 and passes through the point 1, -3. Two ways that you guys can attack this. You can plug it in. Y minus y1 equals m times x minus x1. You have your m, you have your point. Or you can, again, know that my slope is equal to 0. That's reminding me of horizontal line 0, slope y is equal to. So all I have to do is look at my y value, and that's my equation. Y equals -3. Okay, let's look at 15. Getting through it. So 15 says write the equation of the line that is parallel to 3x minus 5y equals 20 and passes through the point 2, -4. So here's the deal. First thing, every single time when you're writing the equation of the line is to find the slope. Parallel, whenever I see that word parallel, I'm thinking, okay, all I want from this is the slope. And I know parallel lines have the same slope. So what I'm going to do is just from this, I'm going to rewrite it in y equals mx plus b form. So 3x minus 5y equals 20. So all I need to do is get y by itself. Subtract 3x. Divide by -5. -3 divided by -5 is positive 3/5. And 20 divided by -5 is -4. Now the slope, because that's all I care about, is 3/5. So that tells me if the slope of this parallel line is 3/5, the slope of my new line that passes through this point is also 3/5. So my slope is 3/5 and my point is 2, -4. So all I did was take the same slope and apply it to my new line. And now I can just plug that into y minus y1 equals m times x minus x1. So y minus -4 equals 3/5 x minus 2. Negative and a negative make a positive. Distribute the 3/5. So y plus 4 equals 3/5 x. And then 3/5 times -2 is -6/5. And then I just subtract both sides by 4. I'm going to do that in my calculator. So -6/5 minus 4 gets me -5.2. To write it in a fraction, -26/5. So my final answer is y equals 3/5 x minus 26/5. Which makes sense. If I were to subtract 4, I would have to get a common denominator. And so to get a common denominator, I'd be multiplying top and bottom by 5. So that would be minus 20 over 5, which -6 minus 20 is -26. Okay, let's move on to 16. Write the equation of the line that is perpendicular, keyword there, to 7x plus y equals 4 and passes through the point -3, 5. So perpendicular, just like over here, all I care about is the slope. Now it's not the same slope, but now it's the opposite reciprocal slope. So I still want to do the same process. I want to get it in y equals mx plus b form. So subtract 7x from both sides. And I have my slope. My slope here is -7. So that means the slope of my new line is the opposite reciprocal. So now it's positive, and then it's the reciprocal. So if this is 7 over 1, the reciprocal is positive 1 over 7. And then my point is -3, 5. So I just used this. I took the opposite reciprocal. And I'm applying it to my new line. And now I can get it, I can use point slope form. So y minus y equals 1/7 x minus x1. Minus and a minus make a positive. And then I'm going to distribute the 1/7. So y minus 5 equals 1/7 x plus 3/7. And then I need to get y by itself. I'm going to do that in my calculator. So that would be, kind of see it, 3/7 plus 5. And then math frac, I want to get it in fraction form, so 38/7. And that's my answer. Y equals 1/7 x plus 38 over 7. Okay, number 17, write the equation of the line that is perpendicular to x equals 5 and passes through the point -1, -2. Perpendicular is super important. And x equals 5 is actually really important to us as well. X equals 5, we know what type of line that is. That type of line is a vertical line. So that means it's a line going like this, right? Straight up and down. Well, what type of line is going to be perpendicular to a vertical line that's going straight up and down like that? Well, a horizontal line. Horizontal line and a vertical line create that 90-degree angle. So this is telling me that my new line is going to be horizontal. So we know horizontal line, we think about HOI, horizontal y, 0 slope y is equal to. So all I care about is my y value. And so my final answer, y equals -2. Okie dokie. We're getting through these. Let's move on to inequalities. That's what those are called. Okay, so first thing I want to do is just distribute on both sides. So I'm going to distribute this negative here and here. I'm going to distribute this -3 there and there. So that's going to get me 11 minus 3x plus 8 is less than or equal to 6 minus 6x plus 21. And then from there, I will combine like terms. So 11 plus 8 can combine to get me 19. And then 6 and 21 can combine to get me 27. I would continue to solve this by moving the negative 6x to the other side because I want to get the x's together. So I'm going to add 6x to both sides. Negative 3x plus 6x is 3x. Bring down that 19. Negative 6x plus 6x cancels, and then I bring down that 27. And then now I can just solve pretty straightforward. 27 minus 19 gets me 8. And then divide both sides by 3. And I get x is less than or equal to 8 divided by 3. So your answer is interval notation. If it helps you to graph it first, then graph it first. So 8/3, we can just put 8/3 here. It's a bracket because it's or equal to, and it's less than, so it's going in the negative direction. So to write that in interval notation, it would be going from negative infinity to positive 8/3. The infinity always has a parentheses, and then the 8/3 has a bracket because of that or equal to. Okay, last page. 3 more problems. We can do it. I think I'm just telling myself that I can do it. So, okay, so now we have a compound inequality. With that compound inequality, what I want to do is get x on the inside all by itself. So what I'm going to do is start by getting rid of the 4. And if I multiply this by 4, I also have to multiply here by 4 and here by 4. So 4 times negative 3 is a negative 12. And then inside is now just 2x minus 3. And then 2 times 4 is 8. Keep going with the problem. So I would add 3. If I'm adding 3, I need to add 3 here, and I need to add 3 here. Negative 12 plus 3 is negative 9. 2x is now by itself, and 8 plus 3 is 11. Last thing, to get x all by itself, I divide everything through by 2. So my final answer is negative 9/2 is less than x, which is less than 11/2. So to write this, sometimes like what I'll do is I just look at this and I know it's just essentially what this is saying is negative 9/2 to 11/2. But also what I can do is look at it as 2 separate inequalities and then kind of graph them together. So one of them I can look at as x is less than 11/2. And now this one, with ignoring that, is saying negative 9/2 is less than x. Now notice how the inequality symbol is looking at the x. It's like wanting to eat the x. So when I write that this way, it would be x is greater than negative 9/2 because the x is facing, or the inequality symbol is facing the x, which is when we flip it, it does the same thing. So to graph that, we have negative 9/2 and then 11/2. I really don't care where you put them. They're both in parentheses. Both in parentheses. It's less than 11/2 and greater than negative 9/2. So those are coming together. And that one is always the easiest one to write in interval notation because it's just hits at negative 9/2, ends at 11/2, and it's both in parentheses. And that's it. Okay, 2 more. Solve and graph the inequality. Write your answer in interval notation. We have an absolute value inequality. Remember, with absolute value inequalities, there's one extra step. So we take into account the original. So the original inequality symbol and the original sign. And then notice how what's inside the absolute value symbol stays the same. We switch the inequality symbol and switch the sign. And now it's just like two problems, solve them each separately. So I'd start here, I'd multiply both sides by 4. That gets rid of the 4 here, 4 and 4. So then 7 minus 2x is less than or equal to 8. Keep going, so subtract 7 from both sides. I get negative 2x is less than or equal to 1. Divide both sides by negative 2, but wait, I'm dividing both sides by a negative. So I am flipping my inequality symbol, and then it's x is greater than or equal to negative 1/2. Now I'm going to also solve my second one. So I'm going to do the same exact thing. I'm going to multiply both sides by 4. And I have 7 minus 2x is greater than or equal to negative 8. Subtract 7 from both sides. And that gets me negative 15. I am again dividing both sides by a negative number. I'm dividing both sides by negative 2. So that means I'm going to flip my inequality symbol, and it's going to be positive 5/2. So negative 1/2, let's put that here. And then 15/2, let's put that here. So it's greater than negative 1/2, so it's going in the positive direction, and less than 15/2, so it's going in the negative direction. So it's similar to 19. It's coming together, except we're using our brackets because of the or equal to. So they're coming together, and it makes it easy for us to write it. Negative 1/2 to 15/2. And that's your answer. Okay, last one. So we have absolute value again. Before I can split it up like I did up here, I have to isolate my absolute value expression. So this negative 5, I need to move to the other side by adding 5 to both sides. Anytime you have an absolute value inequality or equation, you have to isolate the absolute value before you can split. So then I have the absolute value of 3x plus 1 is greater than or equal to 7. And then I can split them into 2 now. Now it's all by itself, so I can do 3x plus 1 is greater than or equal to 7. Same symbol, same sign. And then 3x plus 1 is less than or equal to negative 7. Flipped sign, flipped symbol. I said that switched, but. Okay, subtract 1. 7 minus 1 is 6. Divide both sides by 3. I get x is greater than or equal to 2. Subtract 1 from both sides. That's negative 8. Divide both sides by 3, and I get negative 8/3. So it's less than or equal to negative 8/3, so it's going in the negative direction, and greater than or equal to 2, so it's going in the positive direction. So these are actually going away from each other. So less than or equal to negative 8/3 and greater than or equal to 2. So the way we write that in interval notation, it's going from negative infinity to negative 8/3. We always use parentheses with infinity. Bracket because of the or equal to. Union 2 because there's a gap in between. So 2 to infinity. Always use parentheses with infinity. And that is your study guide. We are done. Again, if you guys have questions, bring it to class. We can go over it before the test. And I will see you guys soon. Bye, guys.